Hello everyone, my name is Ogenete Drio Mamogo and you are welcome to Oakscam Academy. Now if you are new to my channel, kindly hit the subscription button below, also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's lesson, we're going to continue from our series chemicals, equations and formulas. But we're going to be emphasizing on the subtopic empirical formula. So we're going to be learning empirical formula and molecular formula calculations. For the purpose of this lesson, we're going to be learning how to calculate for empirical formula. So we're going to be taking different examples to better illustrate this particular lesson. But first things first, what is empirical formula? Now, empirical formula can be defined as the simplest ratio of atoms of an element in a particular compound. So empirical formula can be defined as the simplest ratio of atoms of an element in a particular compound. That is to say, the simplified, so we can also refer to empirical formula as the simplest formula. Okay, so for example, you are given a compound, let's say C6H12O6, and you are asked to calculate the empirical formula. If we are to do ratio, if you remember ratio in mathematics, right, 6:12:6. So if we are to break this down, we know that 6 can go here 1, 6 here 2, 6 here 1. So meaning that the simplest ratio of this compound is 1:2:1. So that's I'm using to illustrate what empirical formula is. Empirical formula is the simplest ratio of atoms of elements present in a particular compound. Okay, so the first example we're going to be taking is this. Number one says a forensic scientist is given an unknown white substance. The substance is found to have the following composition: 49.8% carbon, 5.19% hydrogen, 28.85% nitrogen, and 16.48% oxygen. What is the empirical formula for this substance? So we want to learn how to calculate this, and it is actually very easy. So please ensure you have your writing materials so that you can follow along. So first things first, when you are given a problem like this, you must write out your elements. That is the elements given in the question. So the elements given in the question are, we have carbon. So the symbol for carbon is C. We have hydrogen, H. We have nitrogen, N. And then we also have what? Oxygen, O. Okay? So once we have written this, the next thing you want to do is to write the percentage attached to these elements. Now, sometimes it may not be given in percentage. It can be given in gram. So whatever is given, you're going to write it first. So in this case, we're given percentage. So we're told that carbon has a percentage of what? 49.8. Hydrogen is what? 5.19. Nitrogen is 28.85 and oxygen is 16.48. So that is the percentage given. Now, the next thing you want to do is to write the mass number. Now, for calculating empirical formula, we do not make use of atomic number. Okay, so what we make use of is what? Mass number. So please don't confuse it. For calculating empirical molecular formulas, what we make use of is what? Mass number. So most times, the mass number is usually attached to the question. But for this question, we're not given. So please just take a mental note of the mass numbers of what? These elements. So the mass number, so let me write it here so I will not forget. Mass number, okay? So the mass number of carbon is 12. Remember, the atomic number of carbon is what? 6, but the mass number is 12. Hydrogen has a mass number of 1. Nitrogen has a mass number of 14 and oxygen has a mass number of 16. Okay, so once you have written the mass number, what you want to do is divide them. So you are dividing the percentage against the mass number. So we're going to be dividing 49.8 by 12. So let's make use of our calculator. If you have one handy, you can easily use that. So as not to waste time. So 49.8 divided by 12, and what we have is 4.15. Okay, so please take note, your answer must be to 2 figures after the decimal. You must have 3 numbers present, so please take note. Then 5.19 divided by 1 is also 5.19. Then we have 28.85, okay, So 28.85 divided by what? 14. And what we have is 2.0607 and so on and so forth. So, but as I said, you must write it to what? Two numbers after the decimal. So we're going to take 2.0806. So this is what our number will be. So we're going to drop 071. Had it been it was 2.067, we will approximate that 7, and here will not be 2.07. But because the number after 6 is also 0, then we leave our answer as 2.06. Okay, then the next one, we have 16.48. 16.48 divided by 16. Okay, so what we have is 1.03. So you see that they all have two numbers after the decimal point. Now, once you have done this division, you are going to select the lowest number from all these four, and you're going to divide all of them by the lowest number. So if you look at this, 4.15, 5.19, 2.06, 1.03, the lowest here is 1.03. So we're going to divide all of them by 1.03. 1.03, 1.03, 1.03. So this is very easy. We're still going to divide. Okay, so we chose the lowest number and we're going to divide all of them by the lowest number. So 1.03 by 1.03 is 1. So let's divide them. 2.06 let's divide 2.06 divided by 1.03, and we have 2. Okay, so let's divide 5. Please make sure you're using a calculator if you can't do this off head. So 5.19 divided by 1.03. Okay, and what we have is 5.0, which is also 5. Okay, so your final answer must be in whole number. For this one, remember I said it must be to two numbers after the decimal. But for your final division, which is when you divide with the lowest number, your final answer must be in what? Whole numbers. Okay, so this will give us 5.0 something. 5.0 is also what? 5. So it's 5. Then 4.15 divided by 1.03. So if you do this division, you have 4.02, but 4.0 is also what? 4. So this is our final answer. So what we have is 4:5:2:1. Okay, so therefore the empirical formula is equal to, so we're going to write down our element C. So what did we get for C? 4. C4. Then H. What did we get for H5? N. What did we get for N2? And then O. What did we get for O? 1. But in chemistry, we don't write 1. So meaning that our empirical formula is C4H5N2O. Okay? So that is our empirical formula. I hope we understand. So we're going to take another example. Please attempt to do this other example. Pause the video, attempt it, and then you play it to see if you are correct. Okay? So let's take example number 2. For our second question, it says, what is the empirical formula of the compound below? So we're given two questions under this. We have 75% carbon, 25% hydrogen, 52%, 52.7% potassium, and 47.3% chlorine. So we're asked to calculate the empirical formula for these two compounds. Okay, so it's very simple. It's just like the first one. So we're going to take this one first. Please take note. For you to properly calculate the empirical formula, you must be familiar with your mass numbers. Okay, so I know we have talked about atomic numbers, we talked about valencies, but you must also be familiar with your mass numbers. So please take out time to learn the mass numbers of your first 20 elements and then other important elements. Okay, so please do that. Then meanwhile, let us solve this question. So we have carbon and we have hydrogen. Remember, the first thing we do is that we write our elements. So carbon and hydrogen. Then what's the next step? Is to write the percentage. I already told you that sometimes you may be given in gram. So please don't be confused by that. Whichever is given is what you use in the for your solving. So percentage, carbon is what? 75, and what hydrogen is what 25. So we're going to write what the next step, mass numbers. Please don't write the atomic number. What we are making use of is what mass number. So what's the mass number of carbon? 12, as we said in our previous solving. Hydrogen is 1. That is the mass number. Okay, mass number. So we're going to divide, right? So 25 divided by 1, we know is 25. Then we're going to divide 75 divided by 12. So what we have is what? 6.25. So remember, I told you that it must be three figures. So we say 0.0 so that it becomes the same. This consistency of numbers. So 6.25, 25.0. So like I said, we're going to be dividing by the lowest number. That is the third step. So which is lower between these two? 6.25, right? So I'm going to divide by this. So 6.25, 6.25. Okay, so this divided by this we know is 1. So let's divide 25.0 divided by 6.25. So if we divide 25.0 divided by 6.25, what we have is 4, which is a whole number. Remember I said that your final values must be what? Whole numbers. So therefore, we have 1:4. So the empirical formula, EF, of this question is what? Carbon, 1. We don't write 1 in chemistry, remember. And then hydrogen, 4. This is what? Methane. Okay, so the empirical formula for this question is what? CH4. So it's just that simple. So please attempt this question, then play the video back and see if your answer is correct. Also, let me know in the comment section whether you are able to solve it on your own or not. Okay, so let's take the second solving. So the same thing, potassium and chlorine, we write the formulas. Potassium is K, okay, don't forget that. And chlorine is what? Cl. Now, potassium is 52.7 and chlorine is 47.3. So I'm going to write what? The mass numbers. So what is the mass number for potassium? Please take note, it is 39. Okay, 39. And then the mass number for chlorine is 35.5. Okay, so like I said, please learn your mass numbers. It will go a long way in helping you solve this. But also, most of these questions come with mass numbers in them. But as you can see, these questions do not come with them. So don't rely on that. Learn your mass numbers. Okay, so I'll be taking a lesson where I will be giving you guys tricks on how to learn mass number easily so that you don't cram so much. So please stay tuned for that. Meanwhile, let's do the division. So when we divide 52.7, so let's divide 52.7 divided by what? 39. Okay, so that will give us 1.3512. But remember, we're only taking the first two. So 1.35. 1 is not up to 5 for you to approximate. So 1.35. So let's divide 47.3. Okay, divided by what? Divided by 35.5. So we have 1.33. Okay, so first two figures. So which is lower between 1.35 and 1.33? 1.33, right? So we're going to divide by this. So 1.33, 1.33. So when we do the division, we already know that this is going to be 1. Okay, so this divided by this. So let's use our calculator to do that. So 1.35 divided by 1.33. So what we have is 1.01, which is what? 1. So 1. So what is our, so we have 1:1. So what is our empirical formula? EF is equal to K1. Remember, we don't write 1 in chemistry. So K1, Cl1. So meaning that our formula is what? KCl. Very simple. So these are some examples of for calculating empirical formula. But I want us to take one more example so that we know that we are certain about what we understand in this lesson. Okay. We're going to be taking these last questions to ascertain our level of understanding. But by now, I want to believe you can attempt these ones on your own. So very quickly, let's solve this question. It says, find the empirical formula of an oxide of iron containing 70.0% iron. So First things first, when you hear the word oxide, you know that oxygen must be what? Present. So if they say it has ion, meaning that this is what? Ion oxide, which is FeO. So meaning that our two elements here are ion and what? Oxygen. Okay? So remember, we're making use of percentage because the question talked about percentage. So what's the percentage of ion? 70.0. What about oxygen? Now you may say there's no oxygen on the board, but there is. Remember, percentage is what? Over 100. So if you were given one and they tell you that it is 70%, how do you get the other one? Let me give an illustration. If you are told that a class has 60% boys, how many percent are girls? What would you do? You will subtract 60 from 100, right? To know the percentage that are girls. Yes. So it's the same thing that applies here. So to get the percentage of oxygen, you subtract 70% from 100. Remember, percentage is over 100. So 100 minus 70 is what? 30 percent. So that is how we're going to get our oxygen. I hope you understand. Okay. So now that we've gotten our oxygen percentage, that's 100 minus 70. Okay. Equal to 30. So that's how we got this. So the next thing is what? To use the mass number. We're given in the question. Iron is what? 56. These are the mass numbers in the bracket. Oxygen is what? 16. So if we are going to divide that, okay, so let's use our calculators. 70 divided by 56 is 1.25. Okay. And then 30.0 divided by 16 is 1.875, which is 1.88. So we approximated the 5 to 7, which gave us 1.88. So we're picking the lowest number. What is the lowest? This one. So 1.25, 1.25. Okay, so this is 1. So 1.88 divided by 1.25 will give us 1.5. Now, in our previous calculations, we have been getting whole numbers, but in this case, we have 1.5. So what do you do when your final answer is not a whole number? Because we cannot just approximate this to 2. Okay, that only works if here is 0. If here is 0, we just know it's 1. But in this case, this can be approximated, but we don't do that. So what you do is that you're going to multiply both answers by 2 to make them whole numbers. So you're going to say 1 times 2 and 1.5 times 2. So multiply by 2. So 2 times 1 is 2. 2 times 1.5 is 3. So meaning our ratio is 2:3. I hope you understand that. So the reason we are doing this is to make it a whole number. Remember, I said your final answer must be a whole number. But you only do this when the value here is more than 4. Meaning that it can be approximated, but we don't do that. So when you have a scenario like this, 1.6, 1.7, what you do is that you multiply by 2 across board, okay, to give it a whole number. So that's the aim. So meaning that our empirical formula is what? Fe2O3. If you remember how to write chemical formulas, I taught it in my previous video. If you are yet to watch that, please check it out in my channel. It is titled How to Write Formulas. Okay, but if you remember that video or that lesson, iron has a valency of +3 and oxygen has a valency of -2. If they swap valencies, what happens? The 2 of oxygen goes to iron and the 3 of iron goes to what? Oxygen. So you see that our formula is correct. So this is the empirical formula for this calculation. I want to believe it's very simple. So lastly, let's do that. What is the empirical formula for the following? We are giving A, B, and C. So let's take the first one. P4 O6. So this is quite straightforward. You're not giving percentage, you're not giving gram, you just ask to find the empirical formula. Don't forget that I told you the empirical formula is the simplest ratio. So what you simply need to do is to get the ratio of 4 and 6. So 4:6. How do we break it down? 2 can go in, right? 2 here, 2. 2 here, 3. Can 2 go in again? No. So meaning that the simplest ratio for this compound is 2:3. So therefore, our answer is P2O3. So this is our empirical formula. Very simple. So let's take the second example. B, C6H9. So 6:9. 3 can go here, right? 3 here, 2. 3 here, 3. Can 3 go in again? No. 3 cannot go into 2. So this is the lowest that it can be. So meaning that our empirical formula for this question is what? C2H3. Very simple, right? So for the last one, please do it yourself. But what we have is BaCl2. So that is 1:2. Can anything go there? No. That is already the same. So meaning I want Cl2. Don't be confused. Do you understand? So it's that simple. So please, if you have any questions as regard this lesson, drop them in the comment section below. Also, if you have other examples you would like me to solve concerning the empirical formula, also drop them in the comment section below. If you have watched the video up to this point and you have not given us a thumbs up, please also do that. And of course, subscribe so that you can be made aware when videos are dropped in my channel. So till the next class, I remain your tutor, Ogenete Drill Mamogo. Have a wonderful day.